Okay, you ready? We're on section 2.4. A lot of content in here, okay? If you get confused or miss something that I say, ask me to repeat myself, because understanding this is essential. Like, this will never go away. You will see this throughout the entire class. So I'm going to teach you how to name chemical formulas and write chemical formulas. And there's a specific method to doing it. There's a right way and a wrong way. And we're going to start with the warm-up just to sort of get you acquainted with this concept, okay? So in the warm-up, you'll notice that on the left-hand column, so right here, they've given us something called cations. Cations are ions, which are charged particles. Cations would be positively charged particles, okay? Some of these are monoatomic ions, meaning it is one atom with a charge, and one of them is a polyatomic ion. So the sodium, calcium, aluminum, and tin, those are all monoatomic, but this one right here, this NH4 plus 1, this is a polyatomic ion. This is actually on the bottom left of your periodic table. I would recommend getting out the one that you started color coding, take it out of its protective covering, because you may want to make some notes on it as we move throughout this section, okay? Okay, now, technically, you should be putting a charge with a number, especially if you're submitting something to Canvas, okay? So thank you, God bless you. Yeah. Thank you so much. Okay, so I just want to make sure you understand that if you say a positive or a negative, that implies that there is a number of a 1 after it. So here this Na plus is really Na plus 1. Okay? NH4 plus is really NH4 plus 1. Like I said, on Canvas, you have to submit a charge and a number. The order that I do it is the charge comes first, the number comes second. Some teachers will teach it where the number comes first, the charge comes later, but that's why you see in this book that they've sort of like put the number in front. So you will actually see me write this as +2, and then this one would be +3, and then this one down here for the 10 would really be +4. Does that make sense? Technically, there's no rule, but this is just the format that I use, okay? Now, along the top, you'll notice that we've got some anions. Anions are charged particles with negative charges on them. Some of them are monoatomic ions, like this bromide, oxide, nitride. The last 3 are polyatomic, hydroxide, sulfate, and phosphate. I'll teach you how to name them and write their formulas in a little bit. Now, this bromide would be a -1. This I would write as a -2 rather than the 2-. This one I would write as a -3. This OH has a -1 charge. It may be hard to see on your periodic table on the bottom left because it's kind of small. So if you want to like maybe make a note that the hydroxide is actually OH -1, that may help you later on, okay? And then this sulfate would be -2. This phosphate would be -3. Okay, now, when we're writing compounds, especially ionic compounds, which I'll talk about more in a little bit, you bring together a cation with an anion. So the cation is always listed first, and then the anion would come after it. If you write it the other way around, it is considered incorrect and it would be marked wrong. Okay, so let's take a look at a couple of these. Here I have a sodium ion. I have Na plus 1, and I have O -2. So I've got the cation followed by the anion. Now, ionic compounds are neutral, so that means they won't have any charge in them, and we use the charges on the ions to figure out how many of each atom we need. You want these charges to add up to 0. So if I've got Na with a +1 and O at a -2, wouldn't I need 2 Nas at a +1 to get the charges to add up to 0? Yes? So that means my neutral compound here would really be Na with a subscript 2 because I need 2 Nas, and then I have 1 O. So Na2O is considered the proper chemical formula, okay? The other way that this is taught is they cross the numbers in the charges. I think you can do either one. So for instance, if you have Na plus 1 and O negative 2, this 1 comes here, this 2 comes here. We don't write the number 1 as a subscript. It will be deemed incorrect. Does that make sense? Okay, there are a couple of other things that you might run into when you do this, but if you follow the format where the charges should add up to 0, this will work every single time. Okay? Okay, so let's take a look at the next one. Na plus 1 and OH negative 1. Well, don't those already add up to 0? So wouldn't I just need one of each? So then my formula would be NaOH. Okay, and then the next one, Na plus 1 and SO4 negative 2. All right, so how many NAs would I need to make the neutral compound? 2, right? Because we have a negative 2 charge here, so this would be a plus 2. So then this would be Na2SO4. And then the last one, I've got Na plus 1 and PO4 negative 3. So how many NAs would I need? 3, because that would give me a plus 3. Right? These add up to plus 3, and this minus 3 would make a 0. So Na3PO4. We good so far?
Ms. Walton?
Yeah.
So on the SO4 negative 2 and the PO4 negative 3,
Yeah.
is the subscript 4 significant in determining the neutral, or is it just like...
So, okay, that's a good question. So this right here, the SO4, by definition, is called the sulfate ion. Okay? I'm going to teach you how to determine that using your periodic table a little bit. So the 4 has to stay. Okay? Same with this. This is a phosphate ion. The PO4, the 4 has to stay. It's just a subscript, stays in its place. Okay? All right. So let's do a few more and then we'll move on. So over here, I've got Ca plus 2 and Br negative 1. How many of the bromides would I need?
2.
2, right? Because this would be a negative 2 and a positive 2. So this would be CaBr2. For the next one, I've got a calcium ion and an oxide ion. So a plus 2 and a minus 2. Wouldn't I just need one of each? So this would just be CaO. Then I've got the next one. I've got Ca plus 2 and N minus 3. 2 and 3 go into 6, right? So then wouldn't I need 3 of these calciums and 2 of these nitrogens to make it 0 for the overall charge? Okay. And then over here, let's watch out on this one, Ca plus 2 and OH minus 1. How many hydroxides or OHs would I need? 2. Okay, now since I need 2 of these, anytime you're writing more than one polyatomic ion, so this is a polyatomic ion because it's a group of atoms with a charge, okay? You have to put it in parentheses. So this would actually be Ca in parentheses, and then you would put the 2 on the outside. If you didn't include the parentheses, what you would be telling me is that you only have 2 hydrogens, but isn't that incorrect? Okay, so that's why parentheses on polyatomic ions are required if you're writing more than one of them.
Would it be wrong to say CaO2H2?
Yes.
Okay.
Okay. Now, this last one, I have a Ca plus 2 and an SO4 minus 2. So wouldn't I just need one of each? We're done. Yes.
What determines whether you change the cation or anion to balance out the equation?
Oh, like have more than one of them? It's the charge on it. So you're just trying to figure out how many of each charge do I need so that they can add up to 0. Does that answer your question?
And you only ever increase the charge.
Yeah.
Why wouldn't you put in parentheses for the CaSO4?
So I've got a plus 2 charge on the calcium and a minus 2 charge on the SO4. So these already add up to 0. So I only need one of each. Okay?
But if you needed multiple, you put...
If I needed multiple SO4s, the SO4 would go in parentheses with the number on the outside. We good? Okay. All right, so let's move on and what I'm going to do is I am going to review monoatomic ions on your periodic table. Because I always get to request for more practice, this is a packet that starts at the beginning of nomenclature, which is what this is, and you've got a key for every single type, okay? So if you want practice during class, or you want practice over the weekend, you've got it, okay? All right, so we're going to start with monoatomic ions first, and then we'll go and write binary ionic compounds. So I'm going to pull up your periodic table here. Okay, let's go over this table in terms of monoatomic ions first. So you have metals and you have nonmetals, okay? The metals are on the left, the nonmetals are on the right. You already color-coded this yesterday. Now, in terms of the metals, everything that has a shaded line over it. So I've got these first two groups, and then I've also got aluminum, zinc, and silver over here. Now, in regular chem, these are the only metals in which I teach charged, that they have assigned charges on. But for you, I'm going to teach you all of them. So what I want you to do is, I need you to understand that there's technically a triangle over those metals, because all of those metals have assigned charges. So everything that I just marked has an assigned charge. Okay, so everything that's in this first column, group 1, also known as 1A, has a +1 charge. Everything in this second group has a +2 charge. Aluminum has a +3, zinc is a +2, silver is a +1. Okay, so it goes 3, 2, 1. Gallium and indium, these also have +3 charges. And then this cadmium has a +2. None of the other metals have assigned charges, okay? So when we name metals that have assigned charges, they are the easiest ones to name. You just give the metal name and then you write ion after it. That is if they're alone. So let me give you an example. If I'm looking at Na +1 and I said, hey, name that for me. This would be the sodium ion, okay? If I said to you, give me the symbol for the calcium ion. Calcium is right here. It would be Ca +2, okay? Same thing with the metals that are in this darkened triangle. If I said to you, you've got the gallium ion. Gallium is here. It would be Ga +3. Done. Easy enough? Okay. Let's talk about the metals that have varying charges. So all of the other metals, which would be and I'm trying to just sort of like outline everything to the best that I can. This isn't going to be perfect. It gets confusing around the metalloids and the darkened stair step over here, okay? All right, now, everything else, I realize I highlighted some of the metalloids. Just go with it for a second. Everything here in the middle outlined in yellow, when you name them, they require a Roman numeral. Why do they require a Roman numeral? That's because all of these metals have varying charges. They could be +1, +2, +3, +4. It just depends. Okay. So that means we have to include a Roman numeral when we're given the charge, or if we're calculating the charge, which I'll show you in a little bit. We also have to figure out what that Roman numeral or charge would be. Okay. So let me give you an example. Iron is right here. So if I said you've got Fe +3 and that was written on paper and I said, give me its name, you would have to say that this is the iron, Roman numeral 3, ion. If you were putting this into Canvas, it would be iron with a space, then the parenthesis, then the capital I's, close the parenthesis, put another space, and then you would write ion. Does that make sense? Okay. Let me pause this video or restart.